Good morning, Stats fans. How are we doing this great morning? Sun's coming up. Sun's out there now. Rain's gone away. Hopefully, the weather's going to start turning a little bit nicer. It's supposed to be close to 60 degrees today, in the 60s tomorrow. So hopefully, you can get out and get some fresh air, do some things on the outside. But please make sure you continue to keep your social distancing. Um, just continue to try to maintain any type of social distance so we don't continue to pass the virus from person to person. Keep that social distancing, and hopefully we can get back to some sort of normalcy here within a while. Who knows what will happen, but the more that we can do now, the better it's going to be in the long run as we go through. So please do keep a social distancing there. Take care of yourself. I hope you and your family are all feeling okay and not having any issues with respect to medical things. I miss you guys. I wish you were back here. Wish we were back into a normal routine again, but we're not there. So we're all in the same boat. But the more we can do now, the better it's going to be when we come back. So, or the quicker we can get back to some sort of new normal here. Today, I posted a problem on on Google Classroom. I posted it. We're going to go through it here. I also posted a worksheet for you. We are going to start reviewing some of the topics that we've done the last couple weeks. So we'll start reviewing those ideas. That's what the worksheet's going to be today. We're going to go back to a type of problem where we're going to try to find a value here. Okay, once again, we're going to still look at the Z values. A member of his senior class will receive a scholarship if they score within the top 5% on a standardized test. If the mean score was 520 with a standard deviation of 31.2, what's the cutoff score to receive a scholarship? Okay, what's the cutoff score? So if we take a look at the mean score is 520. We have a standard deviation of 31.2. Okay, those are the values that we know. Now this is not a central limit problem, central limit theorem problem. This goes back to what we've done before. This is going back and finding the value. So what we look at here is if we look at our bell-shaped curve, here's our bell-shaped curve, our Z bell-shaped curve. Here's our middle value here. And we are looking to be in the top 5%. We want to know what this score is. So this is our top 5%. This is our zero value. And this should be all the same. We're looking for this Z score so we can get this score. Well, if you remember back, this is what was our area, was 0.05. This was our area. If this area is 0.05, what does this area have to be? Now remember, what we had is from here to here, area is 0.50. Okay, that area is 0.50 here because of symmetry. So if this is 0.05 for an area, what does this area have to be? Well, this area is 0.5 minus a 0.05. So we come down to this area being 0.4 995. I'm sorry, my bad. I'm sorry. My brain sort of took a time out there. 0.45. There we go. Does that look a little bit better? If I have 50 cents and I subtract off 5 cents, how much do we have left? Well, that would be 45 cents. Okay, so we have 0.45. Now, if you remember what we did with this, we had the 0, 0 there. Now we go to our table. We are looking in the middle part of our table, this part right here, for an area that's 0.4500. 0.4500. Well, if we take a look at those values, you take a look and try to find it. What we are in between is we are in between two values. Okay, if we look, we have 0.4505 and 0.4495. We have two values here, and the 0.4500 is 5 away from each other. For right now, I would accept either of the values. Eventually, when we get into our next chapter, we'll better define the value to be. It's going to be either 1.64 or 1.65. This comes down to 1.65. This is 1.64. If you take it out more decimal places, it's actually closer to 1.65. But I'm not gonna split hairs over this right now. Okay, what I will accept is I will accept either one of these values at this point. 1.64 or 1.65, does not matter. But the more acceptable one, because if we take it out more decimal places, is 1.65. So that is our Z value for that top 5%. That's our Z value for the top 5%. So if we take a look now, we have the value is equal to, if you remember back to what we did, we had our Z is equal to value minus mean divided by standard deviation. If you want to utilize this is fine, but if you looked at what we did, we multiplied both sides by standard deviation and add our mean. So our value is equal to Z value times the standard deviation plus our mean. So if we take a look, we have 1.65 plus or times our standard deviation of 31.2 plus our mean of 520. So we can clickety-clack that through. We're only finding one value here. 1.65 times 31.2 plus 520. We get a value of 571.48. We're not going to score a 0.48 on a test. So what we have to do is we have 572 is our score that we have to have on this test. Now, once again, if you use 1.64, I would not take off for it. Just make sure you show this. If you use 1.64, once again, the more acceptable value that we will use as we move was 1.65, but I would accept either one at this point. So you had 1.64 times 31.25. Entry. Which is 571.2 or 117. As you can see, it's not going to be that much of a difference. Okay, so our score still is going to be 572. So if I score 572 on this, I'm going to be in the top 5% of the people who took this test. Okay, and that's what we're looking for. This is just another example problem in regards to being able to find values. Okay, I posted a worksheet on Google Classroom with the solutions also that starts to review all the ideas that we've talked about this week, okay, and last week. We have z-values, looking at z-values, just calculating areas and probabilities. We also had these types of problems here. Then we evolved into the central limit theorem. Okay, we still need to continue to cover material with respect to the University of Findlay, so we need to make sure that we continue to push through these things. If you have any questions, feel free to comment. Send me a comment, send me an email, ask me the questions. I'll try to highlight them in the videos. That would be fine. So just try to continue to push yourself through the material. If you have questions, once again, please email me the questions that you have. I hope all is going well once again with you and your family. I hope you're staying safe. I hope you're staying your social distancing. I hope things are going well for you. Enjoy some nice weather. It's going to come in the next couple of days. Get out and get some fresh air. But once again, please don't gather. Keep your social distancing. Other than that, I have nothing else for the day. Please do work on the worksheet that I posted. Adios. You folks have a great day.